Hello, students. Continuing to talk about triangle similarity. Remember, the symbol for similar is this. We've talked about 3 different ways to prove that triangles are similar. You can show that 2 pairs of angles in both triangles are congruent. That means the triangles are similar. You can find out that all 3 pairs of sides are in the same proportion. That makes the triangle similar. And you can show that a pair of sides are in proportion and the angle included between them are congruent. Angles included between them are congruent. So those are the 3 that you could tell me that on the final, and that would be good information because that's something we've talked about. Similar triangles were very useful. So another concept for geometry is the measurement of the earth. So sometimes it's really hard to measure things on Earth, like things that are too tall to measure, and things that are too wide to get across. So this one was from homework, and someone asked me to go over it. This is a situation of a pond. A pond is kind of pain in the ass to measure. You'd have to get wet, you'd have to have some sort of rope of some kind, and it's just kind of messy. So it'd be really nice if we could measure this pond indirectly. So instead of getting into the pond and swimming across and figuring out how long it is, we can do it using similar triangles. So the way this one's set up is people on land decided to measure and create these triangles. And this is on land, so it's easier to measure. They recorded maybe between 2 trees was 60 feet, and that those 2 trees were parallel to the center of the pond. And then someone was probably here and they paced it off. They walked and they know how long their steps are. So they took all these steps and they know each step is, I don't know, maybe 2 feet or something. Have you guys ever paced? It's kind of fun. You measure how long your stride is when you're walking normally, and then you can use that to measure kind of far distances. Just do simple ratios. So someone walked and that was 80 feet, and they marked maybe put a stick in the ground right here, and then they walked another 48 feet, and they got to this point. And because these 2 triangles are similar, why are they similar? Well, we have a pair of vertical angles right here. And we also set it up so that it would be parallel. And if there's parallel lines, there's a transversal, and this angle are what kind of angles? That's right, those are alternate interior. Okay, so we have 2 triangles, we got a small one and a bigger one, and they look like they're similar. And they are similar because they each have 2 angles that are congruent. So if I'm going to solve for x, what I usually do is I'm going to take this triangle and I'm going to rotate it around here so that it's the same orientation. So I'm going to draw it kind of spun around here, and then I'll kind of translate it over. So the bottom is going to be the 60 feet. Where is EB going to go? EB is going to go here. So this is B. This is E. And if I spin it, then A is going to go over here. So I'm going to redraw this triangle next to it. That's really not to scale. This would be a lot smaller. Okay, so from E to B is 48, and then I'm going to bring the measurements with it. After I redraw it, I don't have to look at this triangle anymore. And this is 60 feet. And I might bring the angle markings with it. B was in the same place corresponding to D, and E was congruent to itself, congruent to its vertical angle. So this is the situation. Now to finish this problem, we know the triangles are similar because of angle-angle similarity. And we know these angles are congruent because of alternate interior angles are congruent. And now we have to solve for x. So there are lots of correct ways to set up proportions and some incorrect ways. So you got to think about what it is you want and which proportion is going to help you get there. So the 80 feet is in the same corresponding position as the 48. Okay, so in your proportion, a proportion is two equal ratios. You're going to have some fraction equal to another fraction. In your proportion, you need the 80 and the 48 to go together. So they could either be 80 and 48, or they could be 80 and 48. They need to both be on the top or both be in the same fraction. And then the x and the 60 have to go together. So they could either be in the same fraction or they could be in the same line. Okay. So setting up proportions, you have to practice a bit. And I like to say this is to this as this is to this. So 80 goes with 48 the same way that x goes with 60. It's kind of like this is to that as this is to that. It's kind of like a song in my head. So 80 is with 48 the same way that x is with 60. That's one way I could write this proportion. 80 on the big triangle goes with 48 on the little triangle, the same way that x on the big triangle goes with 60 on the little triangle. You could also set it up this way. You could set it up as 80 over x on the big triangle is the same as 48 over 60 on the little triangle. Okay, and this time I put the 80 and the 48 both in the numerator. Okay, you could also not go from the left triangle to the right triangle. You could go 48 is to 80. 48 is to 80 as 60 is to x. So from the little one to the big one, from the little one to the big one. 48 is to 80 as 60 is to x. All of these proportions, if I solve them, I'm going to get the same answer for x. So I just have to decide, first of all, which one makes the most sense to me when I set it up, and which one looks like the easiest to solve. I slightly prefer having x in the numerator when I'm solving, and there's a lot of ways to approach solving these problems. What I tend to do, because I'm a little bit efficient, is I will use cross products. And even though really the easiest way to do this problem is to divide 80 by 40 and then multiply by 60, because I want to multiply both sides by 60 and that'll tell me what x is. But since I'm kind of stuck in my ways, what I usually do to solve these problems is I do cross products. So I do 80 times 60. This is called cross products. You multiply both sides by 60, and then you multiply both sides by 48. What's nice about that is it takes something with two fractions and turns it into just a problem like this. The next thing I do is I'm trying to get x by itself. So the next thing I do is I divide 48 on both sides, which is kind of weird because I just multiplied both sides by 48, but oh well. So that's 1, and that tells me what x is. Then I pick up my calculator and I type that in. I do 80 times 60 divided by 48. I can do it on a Desmos calculator just to show you. I can do Desmos. I can do graphing scientific calculator. I can do 80 times 60 divided by 48. Enter. It's 100. Okay. Is that reasonable? Does it make sense that that would be 100? Whenever you are done with this problem, you've got to check and make sure you didn't screw up your proportion. So is it reasonable that that's 100? Yeah. 80 out of 100 is the same as 48 out of 60. So then, because these are word problems, you want to answer the question. The width of the pond is 100 feet. Yeah. And it actually asks for X. X is 100 is a perfectly good answer. All right, moving on. Ooh, shadow problems. Shadow problems are good for measuring things that are really tall on a sunny day. So a sunny day, here's the sun. This is the sun, yay, it's bright. This is one of your options for the test on Friday. You can, instead of doing a worksheet type test, you can go outside and figure out how to measure something tall. So we have at the same time of the day, there's a shadow being cast. So it's a sunny day. And it says we have a sign 8 feet high. Maybe the sign is saying someone stuck it in their front yard. What did they say? They said vote. VOTE, really tall sign, taller than a person. Okay, and we know that that sign is 8 feet tall. And the sun is shining over here, and we can see the shadow of the sign. Yeah. And the shadow of the sign is 5 feet tall. At the same time, there's a flagpole somewhere. Maybe it's over here. Wow, it's really high. Okay, it's got a flag on it. Here's the flagpole. I'll do an American flag. Maybe I should do a different kind of flag. All right, there's some stars. Okay, it's also casting a shadow. Its shadow is longer. Oh, I ran out of space. Okay, it's 20 feet, 20 feet long. My picture is not very good, but I'm not going to redo it because I'm tired. It's hard to measure a flagpole. You'd have to climb up there and then you might get in trouble. So it's easier to measure the shadow because the shadow's on the ground. Okay, we know this is 5 feet. We know this is like what you are going to do for practice. We got 5 feet here, we got 20 feet here. We know that this is 8 feet, and we have a situation with similar triangles. So why are these triangles similar? Where are the triangles? The triangles are right here. The sun is shining, hitting the top of the sign, and going down. The sun is shining exactly the same on that one and hitting the end of the shadow. Okay. So we have two triangles. Can you see the triangles? They are both having a right angle to the ground, because when we put signs in grounds, we usually put them perpendicular, perfectly straight into the ground. And what else? And, oh, where's the other angle? Where's the angle that's the same? Remember, it's the same time of day. So the sun is going to hit all the objects down here the same amount. It's the same as the one up here. The angle is hitting and creating, the sun is hitting and creating the shadows. So that angle of the rays of the sun is going to be the same. All right, which is why these triangles are similar. They both have right angles and they both have the same angle being created from the sun. So because these triangles are similar, I drew them really nicely, really lined up. The 8 is going with the H, the same way that the 5 goes with the 20. Okay, so we could write a bunch of different proportions. We could do 8 is to H as 5 is to 20. Okay, we could do H over 5, 8 over 5 is H over 20. I kind of like that one. That's pretty easy for me to do in my head. We could do, I kind of like going from left to right, like 8 is to h as 5 is to 20. 8 is to h as 5, or 8 is to h as 5 is to 20. Okay. However you do it is fine. I'm going to do this one in my head. I could do cross products. I could do 8 times 20. 8 times 20 is the same as 5 times h. And then I can divide both sides by 5. And then I could get what h is, the height of the flagpole. Okay, you could type that in, 8 times 20 divided by 5. Or you could think about it a little bit. What is 20 divided by 5? 4. How many times bigger is this triangle? It's a scale factor of 4, isn't it? 4 times bigger to get to here. So what do we need? We need 4 times bigger to get to here. So 8 times 4 is 32. In this proportion, when I look at this, I say, okay, from 5 to get to 20, I have to multiply by 4. So from 8 to get to h, I also have to multiply by 4. My scale factor is 4. So to find this answer, I can just multiply by 4. What's the answer? 32 feet. Because it's a word problem, we want to go write that in words. We're going to write the flagpole is 32 feet high. And I did not get in trouble for climbing the flagpole. All right, so this is the same situation, and I still have H on here. Avery's putting up a radio antenna in his yard. Strange. Ella tells him that the law, the city, the law is going to limit how tall the tower can be. I'm going to come give you a citation and write you a ticket if it's too high. But Avery's going to be like, nah, I got my math. I'm going to prove that my tower is within the city limits. So instead of taking down his tower and measuring it on the ground, he's going to use the power of the sunshine to do this problem. So it says the art's not drawn to scale, and that's a really big yard. Reminds me of my brother's house in Texas. They had a big fence like that. Okay, so let's just set it up. Everything's here. We need to prove how high the tower is. We have the angle of both Avery and his radio tower are perpendicular to the ground, so the right angles are there. We also have, they put the angle here, which is fine. The angle from the sun shining is going to create equal angles at the bottom there too. So I'm going to do it this way. 6 is to 5, the same way that H is to 40. It's a song. Bum ba-da-dum, ba-da-dum, ba-da-dum. Okay. I'm also a very kinesthetic learner, so I got to point to it. 6 goes to 5, the same way that H goes to 40. Kind of a song, and kind of using my fingers and my eyeballs to line it up correctly. All right, so how many times bigger is this triangle? 5 times what gets me to 40? Times 8, right? We basically just did this problem. So this is times 8. And if you want the option, you can go outside and measure some shadows. Okay, that means that each in this problem is 48, because 6 times 8 is 48. That also rhymes. Kind of. All right, so is Avery going to get a ticket from the law, from the city? A citation, say, your tower's too high. You got to pay us and you got to take it down. No, he won't, because the height of Avery's radio tower is less than, is 48 feet, which is less than the limit in the city? Yeah, good answer to that question. Here's a cool one. Another way to indirectly measure tall things that you don't want to measure, like I don't want to measure this cactus, that would not be fun, is to use reflection. So in physics, the angle of intent, it starts with an I. Maybe if you're taking physics, you can look it up. The angle that you're looking into this reflective surface, either this mirror, is the same as the angle of reflection. So it's a little hard to see in this figure, but this angle right here from his eyeballs into this mirror is the same as the angle of reflection. So this is fun. We tried this last year. Get a mirror and stick it on the ground and figure out how far you are away from the mirror and figure out, look at something in the mirror that's really tall. Like look at the top of something in the mirror. Okay, so this is going to be a right angle to the ground here. This is a right angle to the ground here, this person. And yeah, it's angle again, because we have the right angle is the perpendicular objects on Earth standing straight up. And we have the angle, this physics concept that if you look into a mirror, then the angle leaving the mirror is equivalent. So Esteban's out here looking at the cactus. How tall is the cactus? Okay, what you might want to do is you might want to reflect Esteban's triangle, especially if you get confused about which side goes with which. If you turn his triangle around, it would look like that. And then if that helps you can line it up a little bit more, we'll use H again for the height of the cactus. And H goes with 1.5, the same way that 10 goes with 2.5. So this time I went from the big triangle to the small triangle. So H matches up with 1.5, the same way that 10 matches up with 2.5. Okay, that one we can use cross products. So we have 2.5H is the same as 10 times 1.5. What am I doing? I'm multiplying these two numbers together. If you want parentheses, it's fine, but you don't need them. And I'm multiplying these two numbers together. 10 times 1.5 is 15. And then to finish this problem, I divide both sides by 2.5. Again, I could have just multiplied both sides by 1.5 if I was really thinking, but I don't tend to think as much when I do these. I tend to just do it by using a calculator and just kind of plug and chug. So I need to know what 15 divided by 2.5 is, and that's going to tell me the height of the cactus. Which is 6, which doesn't seem right to me. H is to 1.5. H is to 1.5. The same way that 10 is to 2. Yeah, right. Seems okay. Is it reasonable? 6 meters? 6 is to 10 as 1.5 is to 2.5. So the other way, if you're not sure, you can check it by doing 6 divided by 10 and see if that's the same as 1.5 divided by 2.5. Okay, that actually looks okay to me. The cactus is 6 meters high. And I'm super glad I didn't have to climb that cactus to figure that out. There was an ancient person named Thales. He was Greek, and he got credit for measuring pyramids in this way. This one's kind of different and kind of more challenging. So we have and I didn't go over this one in class. So if you're watching the video, good for you. A rescue helicopter is hovering at an altitude of 3.5 kilometers above the ground. A 90-degree angle is above the ground. It sees over this mountain range a camp site over the peak of this mountain. It says the horizontal distance of the helicopter from the mountain is 2.4 kilometers. So it knows how far it is away from the mountain, and it knows how high it is, its altitude above the ground. If the height of the mountain is 2.8, so that's not on this picture. The height of the mountain is, I'm going to just draw it right here, 2.8 kilometers. What is the horizontal distance of the helicopter from the campsite? All right, this one's different than the ones we had because the two triangles are kind of in one. So I'm going to draw them out separately. I'm going to draw the helicopter one. Here's the helicopter. This is the helicopter. Trust me. Okay. And then I'm going to draw this triangle here. Is that the triangle I'm going to draw? Yeah. I'm going to draw this little one. So this is the mountain. Here's the mountain. Okay. Now for this one, we have the right angles. And then we have, it's essentially an overlapping triangle, right? So this angle and this angle are the same. So these two triangles, and it's hard to see this one. Let me draw it in. I'll draw it in green. This is the triangle I'm drawing right now. That's this, that's this one. Okay. And it turns out that these two triangles are similar because they both have the right angle and they both have the thing. So this is the D. This is 3.5 kilometers. And this is 2.8 kilometers. And this, that's the trick right there. That is D minus 2.4. That's the hardest part of this problem. This length right here is D minus 2.4. All right, it's kind of annoying. There's decimals and there's two variables and but we can handle this, especially if you're good at your algebra. So we have 3.5 is to 2.8. I'm gonna do it the other way actually. I'm gonna do 3.5 goes to D. 3.5 is to D. The same way. 3.5 is to D, the same way that 2.8 is to D minus 2.4. All right, cross products. So we have 3.5 times the quantity D minus 2.4, and that's equal to 2.8 times D. And this is distributive property, so I'm going to do 3.5D minus, I'm grabbing my calculator, I'm doing 3.5 times 2.4. 3.5 times 2.4 is 8.4. And I'm doing 2.8D. I have variables on both sides. We've been practicing that a little bit in the warm-ups. I'm going to, I'm going to take away 2.8D from both sides. So 3.5D take away 2.8D. So what did I do? I did 3.5D take away 2.8D. I still have this minus 8.4 here. And I did 2.8D minus 2.8D. And what is that going to give me? That's going to give me 0.7D minus, too messy. I'll write a little bit smaller. It's going to give me 0.7D minus 8.4 is 0. Okay, getting closer. I'm going to add 8.4 on both sides. I'm going to do that super small. And I get 0.7D equals 8.4. Getting closer. What do I have to divide both sides by? I'm going to divide both sides by 0.7 kilometers. 0.7 kilometers. Okay, and that tells me, look at that. 84 divided by 7. You know that one? It's 12. So someone in the textbook world is being really nice to you and making an answer come out perfectly. So what's the answer? The answer is the helicopter is 12 kilometers from the campsite horizontally, which may be important to tell people who are on the ground who are trying to get to the campsite to rescue people, that it's going to be, if you're not going around the mountain, it's going to be 12 kilometers to get there. Big plan ahead. All right, this one is on the SAT. We'll probably go over it again. It looks like the one we started with. So the SAT likes to put stuff on there too. Summer camp, a counselor wants to find the length in feet across a lake. The lengths represented A, B, B, in the sketch are determined to be 1,814, respectively. That just means in that order. So AB is 1,800 feet. AB is 1,800 feet. Okay. EB is the second one. So the second number is 1,400 feet. I guess I could put units on here. This is really hard to read. BD is the third one is 700 feet. I just want to see if you can read and stick with it. All right, and then the last one, CD, and the last of the four numbers is 800, so that goes here. And it says that segments AC and DE intersect at B, like it shows on the picture. AC and DE intersect at point B, okay, big deal. And angle AEB has the same measure as CDB. They marked that for us already, which is nice. And what is the value of X? Interesting. Are the triangles similar? Yes. Why? They told us these angles are the same, and we have this beautiful pair of vertical angles right in the middle. Yay for vertical angles. Now I just got to line stuff up right. Okay. So for me, I'm going to rotate this little guy. I'm going to rotate him. Actually, I'm going to move him over, and then I'm going to rotate him. Okay, just triangle CBD or BCD. And B is going to land over here. And D is going to land over there. And C is going to come up to the top. Okay. So I kind of pulled them apart and then I spun them around. I translated and then I rotated. Okay, B has the angle there and D has the angle there. And now I need to bring my measurements along. So let me get the measurements on there. Sorry for that. Bring the measurements onto your new picture. It's so much easier if you reorient them so you know what goes with what. So BD is 700 feet. And DC is 800 feet. And we don't know BC. Okay, so I actually have too much information for this problem. That's interesting. So I need to find x, and I'm gonna be weird and erase this for now. I'm looking at this triangle. Maybe I'll highlight it. I'm looking at this triangle and this triangle. And how do they line up? And which parts do we have and which parts do we need? So for this one, we have x goes with 800, the same way that 1400 goes with 700. And then I can write my proportion. X goes with 800, the same way that 1400 goes with 700. 1400 and 700, what's that? Yeah, isn't it? It's just 2, right? It's just 2. So all I have to do is multiply 800 by 2, and that tells me the answer. Okay. So if you're thinking, you don't always have to do cross products. You can use your brain a little bit. You can look at it. You can like, oh, that's going to be 2 times as big. Okay, and you can get it, 1600. So that's what you would bubble in, 1600, and the feet are already on there. So that's how you do those. Work hard, keep learning, be good. Bye.